Physics, Part 201. Number 2, the electron in a hydrogen atom makes a transition from the energy level at minus 13.58 eV to the level at minus 0.38 eV when a photon is absorbed. Calculate the frequency of the radiation absorbed. Planck constant H is equal to 6.62 into 10 to the power raised to minus 34 joules per second. 1 eV is equal to 1.60 into 10 to the power raised to minus 19 joules. We've got a section summary here. Electrons in atoms can have only certain energies. These energies may be represented in an energy level diagram. Electrons in a given energy level may absorb. I beg your pardon, please let me reiterate this sentence. Electrons in a given energy level may absorb energy and make transition to a higher energy level. Excited electrons may return to a lower level with the emission of a photon. The frequency of F of the emitted radiation is given by E2 minus E1 is equal to HF, where E2 and E1 are the energies of the upper and lower levels, and H is the Planck constant. The wavelength lambda is given by lambda is equal to C over F, where C is the speed of light. When an electron absorbs energy from the white light and moves to the higher energy level, a line absorption spectrum is produced. All wavelengths of electromagnetic radiations have the same speed. C is equal to 3.00 into 10 to the power raised to 8 meter per second in a vacuum. There are section questions. Number 1, calculate the wavelength of a radiation emitted when the electron in the hydrogen atom makes a transition from the energy level at minus 0.54 eV to the level of minus 3.39 eV. The Planck constant is H, which is equal to 6.62 into 10 to the power raised to minus 34 joules per second. Speed of light C is 3.00 into 10 to the power raised to 8 meter per second. 1 eV is equal to 1.60 into 10 to the power raised to minus 19 joules. Number 2, the energy required to completely remove an electron in the ground state from an atom is called ionization energy. This energy may be supplied by the absorption of photon, in which case the process is called photoionization. Use information from the figure to deduce the wavelength of the radiation required to achieve photoionization of hydrogen. The Planck constant H is equal to 6.6 into 10 to the power raised to minus 34 joules per second. Speed of light 3.00 into 10 to the power raised to 8 meters per second. There are few exam style questions as well. A zinc plate is placed in the cap of the gold leaf electroscope and charged negatively. The gold leaf is seen to deflect. Explain fully the following observations. A. When the zinc plate is illuminated with red light, the gold leaf remains deflected. B. When the zinc plate is irradiated with ultraviolet radiation, the leaf collapses. C. When the intensity of the ultraviolet radiation is increased, the leaf collapses more quickly. D. If the zinc plate is initially charged positively, the gold leaf remains deflected regardless of the nature of the incident radiation. 2. A beam of monochromatic light of wavelength 630 nanometer transports energy at the rate of 0.25 meter mmW Calculate the number of photons passing a given cross section of the beam each second. Planck constant